Okay. Number 4, problem number 4. Let us think about this one. Given A matrix is rotating about z-axis and the angle is alpha. And find all rotation matrix R that satisfy AR equal RA. So this means there is a rotation matrix, and if we multiply, post multiply, or pre-multiply some rotation matrix, if these two things is equal, then what is this R matrix? So this problem asking about what is this R matrix. So firstly, if we can define this A matrix as some B matrix, and A matrix is known as like this, and we can transform to exponential coordinate. And if we define B rotation matrix, and this B matrix is some rotation axis omega B hat, and the angle is beta, then we can write down like this. And if the AR equal RB, we can transform this R to like this. And if we transform this one is exponential coordinate, then we can write down like this. And there is relationship, this one, as you can see, this one, proposition 3.8, like this. We can convert this rotation matrix and rotation matrix transpose, and this one is go inside. So we can write down like this. So by comparing these two things, we can get this equation. And from here, by this alpha value can be go inside like this, alpha and beta. So this one is, because this alpha and beta is scalar value, we can write down this equation. So the relationship can be written, this relationship can be written like this. So in A, find all the rotation matrix that satisfy AR equal RA. So if this omega B hat is equal this B rotation equal A, then we can set omega B hat is equal Z and alpha equal beta. Then this equation transformed like this. This two things is erased, and this one becomes Z. So the relationship is like this. In that case, Z direction is here, and Z direction is here, and if we rotate Z direction R, so even though any angle rotation about Z-axis remains also Z-axis. So R is any G rotation is possible. So this is the solution of A. And secondly, the B, given rotation matrix A and B. So in this one is about this one. Yeah. So the case is alpha beta is not same. So if the B rotation is about the z-axis and there is angle beta, so in the given condition, omega b is z and alpha is not equal b, then this equation can be like this. So if A is not equal B, in the case, even though this one, the size of alpha and beta can be equal. For example, 3 minus 3 is not same, but the size of 3 and minus 3 is equal. So in that case, by gathering all these conditions, this one, then it should be alpha equal minus beta. So this alpha equal minus beta, so this equation becomes like this. So as a result, R should be like this. There is z direction, and even though any rotation vector on xy plane, and if we rotate minus pi or pi, this z direction become the minus z direction. So the solution is theta is pi or minus pi. The axis is some rotation axis lying on xy plane. All the axes lying on the xy plane can be possible. So this is the solution of B. And in the case of alpha beta, the size of the alpha beta is not same. In the case, this kind of things, in the case, this one is not satisfied, so there is no solution. And then about C, and in case of C, problem C, is asking about arbitrary rotation matrix that satisfy this one. So in the case, what is R? So in case of C, any rotation AB, so A rotation expressed like this, and B rotation omega B hat beta, and then we can express the relationship like this. So we can divide the solution in case of this axis is same, and when the axis is not same. In case of axis is same, there is two cases. Alpha beta is equal. Then we can write down like this, because omega A and omega B is equal, we can write down like this. And in the case, R is any axis rotation about omega A. or omega b, because these two things is same. We can write down this way. And if the omega and beta, alpha and beta is not same, in the case, when the size of the alpha beta is equal, then it should be alpha equal minus beta. Then the solution is like this. This solution is almost same with this one. So in the case, the rotation R equal rotation omega t theta. In here, theta is pi plus minus pi, and omega t is lying on some omega t perpendicular plane. This solution is almost the same with this one. This case is when the omega t this omega a is z-axis. But this case is more general case. So when the omega a is some general rotation axis, then we can define omega a here, and there is some perpendicular plane. Yeah. This one is this one is omega a perpendicular plane. So in this plane, any rotation axis is omega t, and the pi is the zeta is plus minus pi. So the resultant axis should be the minus value of omega a. So this case is this one. And if there is no, if alpha beta, the size of alpha beta is not equal, then there is no solution. This procedure is same with this one. And the other case is about the omega A and omega B is not same. In the case, there is three cases. So if the omega A and omega B is not equal, and also alpha beta is not equal, then there is no solution. And if alpha beta is equal, then the solution is like this. In the case, the general solution is R is omega t and theta. Theta is plus minus pi, and the omega t is the vector sum of omega A and omega B. So if the omega A and there is some omega B, and the vector sum is this one. So omega t here. So by using this omega t, and we rotate plus minus pi. So this is become the R rotation. And if the alpha and beta is not, in the case of this one, alpha beta is not equal, but the size is same. In the case, alpha beta is alpha is minus beta. So in the case, this one becomes the solution. So in the case, omega A, omega B, and minus omega B the vector sum of this one become omega t, and plus minus omega t, this one and this one, and plus minus pi equal the solution. So this problem was a little bit complex, and it might be difficult to solve, but this one is quite important problem. So let's continue to problem 5. This one is about the homogeneous transformation matrix. So consider robot arm mounted on the spacecraft shown in the figure 3.24, and which is frame attached to Earth E. Earth, there is Earth frame here, and satellite frame S, and spacecraft A frame, and robot arm frame here. So let's solve A first. Given TEA, TAR, TES, find TRS. Because these three things are given, we can find the TRS. Because TRS, the leftmost base is R. So in here, there is R. So we can transform this one, TRA, and then there is A, and there is A. So we can use this one, TAE, and then TES. And this one is equal to TAR inverse. And this one is equal to TEA inverse, TES. So this one is given. So we can calculate TRS. And suppose frame S as in T. Okay. Suppose the frame S origin as seen from E is 1, 1, 1. So some position of S from E based on E. So this one is E and this one is S. So this kind of PES is 1, 1, 1. And then write down the coordinate of S frame S origin frame R. So in here, we should find out PRS. So in the case PES, some TR. If we multiply TER, then we can find the PRS. So if we calculate this one, we can find out PRS. In the problem, we have TER. TER is equal to -1, 0, 0, 1, 0, 1, 1, 1, -1, 1, 1, 1, 1, 1, 1, 1. In the case, we should find out TER inverse. So this one is transpose of this one, minus 1, 0, 0, 0, 1, 0, 0, 0, minus 1, 0, 0, 0, 1. And this one becomes R minus minus 0, 0, 0, 0, 0, 1, 0, 0, 0, minus 1, multiplying 1, 1, 1. This one becomes minus 1, 1, minus 1. And this one becomes 1 minus 1, 1. Therefore, we can calculate PRS equal when we calculate this one, we calculate it by T inverse equal R transpose minus R transpose P. We by using this equation, we calculate this. We calculated this, and we can finally we can calculate minus 1, 0, 0, 0, 1, 0, 1, 0, minus 1, 0. Multiplying T, yes, 1, 1, 1, and dummy 1. As a result, this one is 0, 0, 0, 1. So the position vector P RS is 0, 0, 0. Okay. So by in this solution, we can confirm that the position of R and S is equal. And then the final question is about the screw axis. The twist. The twist is given 0 to 2, 4, 0, 0. This one is omega and V. So we can calculate omega is 0 to 2 and V is equal to 4, 0, 0. Okay, the twist can be written as this equation. So twist nu is omega V, and this one is S hat zeta dot minus S hat zeta dot plus Q plus H S hat zeta dot. And the general calculation of S prime is done by this equation. S hat equal omega over omega hat, the size of omega, and theta dot equal omega size, and V, it might be confusing, but this V and this V having same symbol, but we using this V is not this V. The normalized V is calculated by this equation. Therefore, the size of omega equal 2 square root is 2 root 2. So S hat equal is 0 root 2. Yeah, this one. And V, the normalized V becomes, and this one becomes 2, 2, 2. So root 2, 0, 0. And H can be calculated by this equation. Omega hat transpose V over theta dot. Omega transpose V over theta dot. In here, omega transpose is 0, 0 to 2 plus 4, 0, 0 equal 0, whatever we choose theta dot. So we calculate almost things except Q. In here, H is equal 0. So minus S hat theta dot cos Q equal V. This one is 4, 0, 0. And this one is same with the original omega. So the original omega was 0 to 2. So minus cos Q equal 4, 0, 0. Okay, to find out Q, we need to calculate some equations. So okay, we need to find if we define Q as AI, BJ, CK, then we can find out minus 2J plus minus 2K cross product AI, BJ, CK. This one becomes E, calculate this one, minus 2 EAK, minus, so EAK, and this one becomes 0, and this one becomes minus EK, JKI, and this one becomes KIJ, and this one becomes KJ minus I plus EBI. So as a result, EBI minus ECI minus EAJ plus EAK. So in here, the y-axis and z-axis component is 0. So A, obviously A equals 0. And this one, E, B minus C equal 4. Therefore, B minus C equal 2. Then Q can be some point. If we choose P equal 2 plus C, then 2 plus C, C. Yeah, Q becomes like this. So the selection of Q can be multiple. But if we draw the skew axis, let me think about this. There is x-axis and y-axis, z-axis. And in this problem, skew axis was 0, root 2 over 1, root 2 over 1. So the direction of this one is some kind of here, root 2 over 1, root 2 over 1. So some direction of this one. Because this one is unit vector. This one is the skew axis direction, basically. But is S skew axis displaced by Q vector. So in the Q vector is 0, 2 plus C and C. So if we choose some point in Y direction, let's choose this one. Let's choose, here is 1. So if Q point is located on y-axis is equal 1, then C should be minus 1. So Q point becomes some kind of here minus 1. So this is Q point. Then the resultant skew axis becomes the same direction of parallel direction, some parallel direction with this one, and this parallel axis, the parallel axis goes through the Q point, and this axis becomes skew axis. Because the Q point can be multiple, because some point on the skew axis can be Q point. So if you choose some kind of this point, then you can get another Q point, but the Q point should follow, should on the skew axis. So all the point on the skew axis can be Q. So one of the Q value is this one. So the resultant solution is like this. Okay. There is the interpretation of the midterm exam. So I hope it might be helpful to understand your midterm exam. And we will continue to the forward kinematics. After midterm exam, we will learn about the forward kinematics. Okay, thank you.